Here's pre-calc. This is the focus problem 7-128, and it says given this reciprocal function or rational function, rewrite it in the form y equals k plus a over 2x minus 3. So I guess we'll do that first. So we have to rewrite it, and we learned this one time, and it kind of reminds me of partial fraction decomposition. But one of the ways that the book showed us, let me cover up all this other stuff. The book showed us that you can break this top part up. Like if I wanted to, I could write this as 2x plus 2x. Or I could write it as x plus x plus x plus x plus -1 plus -1 plus -1. I can decompose this top part however I want. So before I'm a little rusty on it, so I realized that I can at least get a giant 1 out of here if I decompose this into 2x minus 3 plus 2x minus 2. Because see, they still add up. The 2x and the 2x makes the 4x, and the -3. And like there's nothing illegal about doing it that way. And then I got a giant 1 right here. And so I can rewrite this as 2x minus 3 over 2x minus 3. And then I'm left with 2x minus 2 over 2x minus 3. But then I realized I think I can do it again, because I can rewrite this top part as 2x minus 2, 2x minus 3 plus 1. Because if it was minus 3 plus 1, then that equals -2. So I did write it like that. I wrote it as 2x minus 3 plus 1. Because -3 plus 1, doesn't that make -2? And don't we have a giant 1 now? So, and then that left me with just a 1 up here. So this part turns into another giant 1. And then I've got this left over my denominator, and then I can combine these two 1s, and I got, this is my final answer. And then I remembered, hey, wait a second. If I knew how to do long division, I could do long division on it. I think probably every single one of you knows how to do long division. So the way you do long division, if you want to not do it this way, because you see there's a lot of steps here. Actually, I could have rewritten it all. I could have done a lot better with this, but I didn't. I had to do it in 2 steps because I didn't see that I could do it all in 1 step. But if you go here, you just take the numerator and divide by the denominator. And then the way you do this polynomial long division is you say 2x, how many times does 2x go into 4? And then you say, well, it goes in 2 times. So then you go 2x times 2 is, I didn't have the signs there yet. 2x times 2 is 4x. And then your next step is you go -3 times 2, and you write the answer down. It was actually -6 over here. But since I want to subtract my 4x minus 6, I change the signs. So then it becomes -4x plus 6. Then I add. Well, because really I'm subtracting, I'm adding opposites. So I've got 1. That's my remainder. So that got me there a little bit quicker. I got 2 plus 1 over 2x minus 3. So either way that you do it, you can take this function, and now this, I don't know if you recognize it, but this is graphing form of a reciprocal function. Like we have a parent function that goes like this. And we know we can go like x minus h plus k. Like we know that about h and k. This is k right here, and it'll lift the function up by 2. So I just thought I would draw the function. I know it's lifted up by 2, so I wrote a little dotted line. It's going to be my asymptote. And then this down here gives me the vertical asymptote, because we know that we can't plug in numbers that make 0 denominators. So we can go 2x minus 3 equals 0 and find out what number makes a 0 denominator. You might already be able to see that it's 3/2. 3/2 is like 1.5. So if this is 1 and this is 2, this one right here is 1.5. That is where I can't, it's like undefined right there. I can't put 1.5 into this equation or else I'll get a 0 denominator. So there is a picture of my graph, and why did I go through all that is because they asked me what are my asymptotes. Like, let's see what letter B says. State all the asymptotes in the graph. So I found 2 of them. I found this one. This is y equals 2. And I found this one, x equals 3/2. And so that's all they asked me to do for letter B. And then letter C says, take the limit of the function as x approaches negative infinity. So I look at my function. That's why I graphed it on the paper, so I'd have it. I'm going to let x approach, negative infinity. So negative, it's going that way. So what is my y value getting closer and closer to as my x approaches negative infinity? Well, I think it's 2, so that's why I wrote 2. And then here, evaluate the limit of the function as x approaches 1.5, which is my 3/2, from the right. So I'm going to approach from the right. I'm approaching 3/2. So I guess I'm going to go all up into infinity. Right? If I were to approach it from the left, I'd go down. Is that all? I think that's it.